I have opened the Revit project from the previous design phase and saved it into a new name. And we will now take a look at the development of the model in this phase. The model development and the output material to deliver in this phase will in the real world be agreed in ICT agreements and delivery specifications. In a school situation like this, it will be highly determined by the time allocated to the individual phase. In this case, it would be an idea to ask these questions with this downpipe in mind. What is the scale of our overall plan? If it's a facade in 1 to 500, it's not easy to see the downpipe if it's visible at all. And then what is the return on investment? I mean, time equals money in the real world. So you can ask yourself these questions. Do we need to visualize it? If it's an architectural expression, it will be visible on a rendering. Do we need to quantify it? Do we need to take out quantities of this model? How hard will it be to model? And how many views will it be seen in? And the last one, it will be quite visible on a lot of views. We can see it on the plans. We can see it on all the facades. We can see it on perspectives. We can see it on sections. So the return on investment on this downpipe will be that it's a good idea to model it in 3D. In the early design phases, the use of curtain wall is very intuitive, but if it's a window or door delivered by a window manufacturer, then it's a window and not a curtain wall. Instead of having a curtain wall like this, then I have created 3 equal size windows, and that will make the ordering of these windows very easy just by taking out the schedule of all window sizes. And as you can see, it fits into the brick measurements, of course. If you want to know how to create your own 3D families, for example, a window, you can see this video that will explain the basic fundamentals in creating family from scratch. Now let's try to take a look at some of the other improvements that we can add in this phase. For example, the cavity closure. If you're using windows from the VIA template, you can select a window and just add an interior end cap of lightweight concrete, for example, as you see here. You can change the length of the end caps by selecting other end cap types. If you would like to define your own length of those end caps, you have to open the window family. And here you can see that this is just a detail item attached to the side of the windows, and you can then create your own types if you would like to do that by duplicating an existing one, renaming and changing the depth of the end cap, and then load this back into the project. If you're using template based on Dan edu, as this one is, you can see we cannot apply end caps automatically. We have to do that manually, or we can play around with this wall closure that is also used for controlling the end of wall or openings in general. But if we would like to add this detail item, then under generic model end caps, lightweight concrete, and then we can add that under annotate, detail item or detail component, and then we can choose the correct size And then we can insert it in this corner here. Just to show you what it is, as I said before, it's just a 2D detail item. So if you select it and say edit family, you'll see that this is a filled region with the fill pattern lightweight concrete. And you can see that we have two different lines. So if I say edit boundary, you'll see that some of the lines are visible and some are invisible, as I'll show you here. So if you select this line, you'll see it's invisible, and this one as well. That means that it looks like the wall is melting together when we see it. If you would like to have another size, it's just selecting it, edit type, duplicate, rename, and then change the dimension. And then we can mirror this to the other side like this. Another improvement that we can make is that we can put a tag on the windows. For example, if we would like to have the number tag, the mark value, under annotate and tag by category. Another improvement we have to do to make our model consistent is the area over this window. As you can see, we have the roof is going to the inside. We have to fix that. First of all, you can see that we have the gutter and the roof is going to the inside. So if we select the roof and grab this handle, as you can see when I make this visual style wireframe, select the roof, we can take the handle and drag the wall onto this side, or drag the roof till this side of the wall. And then we need to fix the wall. We haven't really thought about how to fix this. I think it's a bit difficult to make bricks along the roof, so maybe it should be a light construction or something like that, but we'll leave that for now. So I'll just show you how to complete this area. So that will be edit profile and then create a new area. Again, it's a good idea to turn on wireframe so we can see what's behind, because we would like to have the inner side of the wall to go along the underside of our roof construction like this. And as the last thing, I would leave you with a comment on stacked walls. So if you would like to have that the stacked walls will be broken up into individual walls, you can select a stacked wall, in this case the foundation, and then you can right click, select all instances, and then say break up. Then it will be converted into individual basic walls. Since we started this series of videos, we have worked in the architectural discipline model. We will now look at some of the engineered disciplines associated with a project such as this. In the real world, structural engineer is responsible for all supporting building components. You can choose to follow this example, where the load-bearing parts are transferred to their own discipline model. I will start selecting all load-bearing external walls in the project. Most of our external walls are load-bearing, so I select most of them, and as you can see, when I have selected all my load-bearing walls, I can select that the selected walls should be structural. Then I select all the internal walls that I think might be load-bearing for some reason, and I set them to structural as well. And as the final part in preparing this architectural model for the structural engineer, I select the floor or the two floors that I have in my project and change the setting to structural as well. I then save my architectural discipline model and close it down. I will create a new structural model based on building template from dan.edu, and I'll save it. So now remember that we are not working as an architect now. We are working as the structural engineer, so we'll close down the section concerning architectural and we will focus on structural. So first I will insert my architectural model, origin to origin. And again, remember, as soon as I create a new 3D view, it will automatically set by the architecture discipline, but this is, again, this is structural, so we change it to structural. First of all, I will hide everything that we don't need for now, so that means everything but walls, structural framing and structural beam system. So if we look into Decon and other model specification documents, then we can see that actually our beam system model, we could have started that up much earlier. But again, this is a school situation, so note also that we haven't applied foundation on the inner wall, so remember that in your own project. So now I'll prepare the creation of our beam system. So I'll create a section through the building. It's not visible because it's an architectural discipline, so I change it to structural. And because I would like to copy the levels from our architectural model, I will delete those floor plans and my levels that I have. As you see, if I open my section, we still have what I did before was that I deleted the floor plans. Still need to delete the levels, so I select the levels and delete them. I'll leave the roof because I'm not using that one, so I'll leave that. And then under collaborate, I will copy monitor my architecture model. So if I open option, I can change settings on levels, grids, columns, walls and floors, I would like to have a prefix S before my new levels, so I can see the difference, what is coming from the structural model, what is coming from my architectural model. And now I have new levels in my project. Then I can create new floor plans. Again, they will be automatically placed under architecture. So I open architectural floor plans, select the 3 levels I just made, and change the discipline to structural. So now I both copy and I monitor those levels coming from my architectural model. So if the architect changes the height of some levels, then I'll get a notification in my model here. So now I'll visually prepare the creation of our beam system. So I open these 3 views and tile the view so I can see all 3 views at once. I go to Structure tab and start Reference Plane and pick Line. Now I would like that the top of my beams will be just underneath my roof covering. And to be able to model the beams on this reference plane, I have to rename them. So I look at my grid lines and name them so that roof surfaces are recognizable when we are on the floor plan. So we have all in all 3 surfaces that we would like to, where we would like to apply our beam system. So we have to move the section a bit like this. So now I have renamed 3 reference planes and I'm now ready to model my beam system on top of those reference planes. Remember, we need to create reference planes where we have the ridge of our roof. Remember to drag the end of those reference planes down so that they are in our section plane, so they are visible on the floor plane. So I would like to have 2 floor plans, a section and a 3D view. And to be able to see the whole roof, then we move the cut plane a bit so that we can see the whole roof. And the gutters are a bit annoying, so we'll hide that before we start doing this. So now we are ready to begin and create our beam system. So I start beam system, and before I begin to model the beam itself, then I need to remember to change or to set the work plane for our beams. As you can see, this is our work plane. So I take the rectangle tool and create the first beam system or the boundary. I'll start just on the grid line and see if I can find my reference plane I created before at the ridge. Maybe it's not possible, but we'll change them afterwards. So this will just be not very precise, but we'll change that afterwards. The beam direction we have to change, and we set the fixed spacing between the beams to 600, and our 295 beam is not in the system for now, so we change the type in a while. So we select one of the beams, edit type and duplicate, and change that to 295. So we have the correct size of our beam, and I can then change all beams in the system just by changing the beam type in the beam system. Then I can create the other two beam system. Remember to change the work plane while we do it. If we take a closer look at the beam system, we'll see that the beams are laid out by a justification called center. That means the beams start from the middle and then to the sides. So if we change that to beginning, we'll have the beams to start from the same side, if that is what we want. And then you can see we just need two beams at the beginning, so we can copy that, and in the other end we can just select one beam and copy it so that we have the correct amount of beams in the project. I wasn't that precise when I created the beams, so we want them to be very precise so that we can take out maybe quantities of those beams, length, the correct lengths and stuff like that. So I need to change my beam system, or my boundary of my beam system, a bit. So I'll do that. And just to show you, um, if you want to have an opening in your beam system, for example, if you have a staircase coming up through, then you can edit your boundary and create another rectangle inside, to create an opening in the beams. And if you want to have beams going in the other direction to complete this opening like this, then you can just create a single beam and adjust it like this. Another option, if this should be perfect, then you can see that if we use the cut tool, we can cut away the end of our beams so that they are perfect together like this. Then we sketched a very thin roof in the beginning. Remember that? At the facades, we would like to have a slimmer look of our beams. So if you would like to cut away something of your beam, we need to take a look at the beam family. You can see we have a beam, and then I have made a void here to cut away. And we then load this into the project, and let's try to see if we changed the beam type to the one I just made with the cut. Yeah, we need to change them. So select beam direction and move the boundary line to the other end, then it will be changed. And the last one we have here is one of the manually beams we placed, so we have to change that as well. When we're doing a visual check using a section box in our 3D view, we'll find out that we actually need some beams and columns in our project, but you have to figure out that by yourself. A bit earlier we talked about what should be in the architect discipline model and what should be in the structural engineer model. In this case, we need to have the load-bearing external walls as a part of our structural engineer model. So again, we copy monitor the external wall that we have from the architect model, and we copy that into our structural model. In this example, we want to have the inner leaf of our external wall as our load-bearing part. So that should be a part of our structural model, and the insulation and the outer leaf, the brick, should be the architect's. A way to do that is to copy monitor my structural walls. So if I hide the architect's model, what is left is those two walls and my beams. So if I want to separate the three layers in my external wall, I can select them and make them into parts. Then I can control the different layers. As you can see here, I can select one layer in my wall. It's more visual if I turn on shaded view. You can see what is insulation, what is lightweight concrete, what is bricks. So if I select my brick, it's not a part of the structural model, it's the architect's. So I hide those two. I select the insulation and hide that as well. And now we have the load-bearing part, my structural wall, that is the structural engineer's discipline. So if I want to reshape this, I can turn on the handles, and then I can drag this, and then it's close to perfect what we're supposed to see on the building site when they start to erect the building itself. One of the major tasks in a design project like this is to see if there is any clashes between the discipline models. Here we have a ventilation model. And we will now try to see if there are any clashes between this discipline model and our structural model. So again, we'll link this model into the project. If I want to create a clash detection between our structural model and our ventilation model, under Collaborate, I can start interference check. I can then choose among different projects, as you can see, and I can then see that when I create the interference check. I get a report saying that we have some clashes. If we click show, you can see that some of our ventilation ducts will go through one of the beams. But I'll leave that, and I will then save this project, and you can then decide to link this back to your architect model or project, so that we can have all our documentation drawings placed in one model. Again, if this was the real world, then we had different discipline models. But since this is a school situation, I think it would be okay to link our structural model back to our architect model. Somewhere, as you can see, we have double geometry, and I think that the cut that we have in our beam is not according to our architecture or architectural ideas, so we need to go back and change that. We'll leave that for now. But if again, we have some double geometry, and if we only want to have the structural beams in our project from our structural model, you can see this is the structural model that we have. So we have double geometry. So if I enter the view template and find the Revit link, you can see if I want to control the visibility of the specific building components, then I need to go and say custom, and then under model categories I will turn off everything but the structural framing, like this, and then it looks the way that I want to have it.